Hey kiddos, hope you're doing well. I'd like to introduce some coordinate geometry ideas, or reintroduce some of these ideas so we can build from them next week, right? We get into some more fun stuff. So coordinate geometry is kind of a nice mixing of algebra and geometry, and what we're doing is we're looking at points, lines, and planes, kind of within the context of a numbered system. So we have this axes, right, that we create. We have an x and a y. And of course, this is the x-axis, right? The axis going left to right, the horizontal axis. This is the y-axis, the vertical axis. And the point at which they meet is right here. That's called the origin, right? We have three quadrants going counterclockwise. 1, where everything's positive. 2, 3, and 4, right? So this idea was credited to René Descartes, a famous French philosopher, mathematician. I think it was French, maybe Italian, I'm not sure. So regardless, let's go over some basic formulas, and then we'll see if we can use them and build from them. So what we're doing is we're going to name two general points. And so I'll put a point there. And if we do want to get specific, that's, of course, to get that value of that point, it's I move to the left, 1, 2, 3, 4, 5, 6, 7, 8. So the x value is -8. And down 1, 2, 3. So the y value is -3, right? -8 is the x value, -3 is the y value. Right, so this is how we write it, -8, -3, right? There's our point. Okay, but let's call that something a little more abstract so we can create some general formula. So I'm going to call that x1, that point, and then the y value, oops, the y value, I'm going to call y1. Oh, let me get that back. x1, and then the y value I'll call y1, right? Which means the x and the y values go together. The x1 and the y value create an ordered pair. Okay? Just like -8 and -3. And I'll put any old point right over here, and I'll call that point x2, y2, for lack of a better word. x2, and then y2 for the y value. Okay, so that said, given that setup, I want to quickly establish or reestablish how we can find the distance between those two, how we can find the midpoint of that segment with endpoints x1, y1, x2, y2, and how we can find the slope of the line between them, right? So let's create that segment. And let's first start with slope, right? And slope essentially is the rate of change. Now, since it's a line, the rate of change will be constant. That's what makes it linear. But the slope between those points, assuming it is linear, the line between those 2 points, is essentially the rate at which it's rising or dropping over the rate at which it's running. Okay? So slope, I'm going to call m. So slope, I don't know why it's called m. It's basically rise over run, right? Rise or drop over run, right? And run, we always move from left to right. Okay, it's just a standard. Right, so let's quantify that. The rise essentially is the difference in the y values, right? It rises from this y value, y1, to this y value, y2, right? So we can really in either order, just the difference of the y's gives us the rise, right? So it's y1 minus y2. Now we can also do that in the other direction, as long as we're consistent with our x values in the run, which we'll do now, right? So that's one way, one of the two ways to describe the rise, right? So it moves from left to right, from this y value, y1, to this y value, y2. Therefore, the difference, basically the length of this piece right here, would be y2 minus y1, really, or the absolute value of y1 minus y2. The run, I'm going to think of it in the same way. It's basically just the difference in the x's, right? The change of x. Well, we start over here at -8, and we move all the way over here to 4, right? So to get the change, the run, the change of x, since I started with y1 for my change of y, I therefore have to start with x1, this guy, in my run, my change of x. So it's over x1 minus y1, x2 rather. Okay. And of course you can certainly switch. On top it can be y2 minus y1, and then the bottom would be x2 minus x1, right? Slope is a very important idea in math, particularly as you get into calculus. But for lines it's really easy, right? It's just the rate of change, the rise over the run, change of y over change of x. Okay. The midpoint is easy enough to get to, right? So I'll put that midpoint here, construct. This program actually does it for me. It's nice and easy. But here's the midpoint. And to get the coordinate for that midpoint, and it is a coordinate, it is what essentially we think it should be, right? The x value of that midpoint is the average of the x's, right? And that makes sense, just as logical. So it's essentially the average of the x's, and we can write that out as x1, oops, we add them together, plus x2, so we take the two x values, add them together, we divide that by 2, that's how we get the average of two numbers, two x values in this case. So the x value of the midpoint is the average of the x's, and in the same way the y value will be the average of the y's. Can I copy and paste that? No. So the average of the y values would be y1 plus the second y value, y2, all over 2. Right? So that's how we get the coordinate for the midpoint. Right? I'm going to take the two x values, find their average. That will be the x value of the coordinate of the midpoint. Then take the two y values, find their average. That's the y value of the coordinate of the midpoint. Okay. And then finally we have this distance formula. We can find the distance, and because we're not finding the distance between two numbers on a line, because we're now working in two dimensions with an x and a y value, we have to get a little more creative than just taking the absolute value of their difference. So we have to use a derivative of the Pythagorean theorem. It's actually the same thing, but this is really the Pythagorean theorem in disguise, or not so much in disguise. So the distance between those 2 points, d, is the square root of a whole bunch of stuff, right? And the whole bunch of stuff is the difference in the x's, which is x1 minus x2. And I'm going to square that, and I'll explain where these come from in a hot second. So I want to square that, plus, still under the absolute value, the square root rather, the difference in the y's squared. And so the difference in the y's will be y1 or y2. The order doesn't matter for this, by the way, because we're squaring it anyway. y2. And I'm going to square that as well. Okay? So there's your distance formula. Bada bing, bada boom. And you might say, well, that's kind of crazy. And it looks kind of crazy. It looks like a lot. But if I square both sides, I get d squared equals, and that radical goes away, difference in the x is squared plus difference in the y is squared. And essentially that's exactly, in no uncertain terms, the Pythagorean theorem. D being our quote-unquote c, the Pythagorean theorem gives us, c squared, d squared, equals, and then this piece right here of the right triangle that I could make, if I wanted to, that has a length of the difference in the x's squared, right? Really the difference in the x's, as far as the length, the absolute value of that, but when I square it, it doesn't quite matter. And then the other piece to that right triangle I could create, this piece has a difference in the y's squared as its length, right? So if you want to get cheeky, you never really have to memorize this distance formula. You can always use Pythagorean theorem, right? Here's your difference in the y's as far as the length. Here's your difference in the x's as far as the length. So difference in y squared plus difference in the x's squared equals c, or d squared, right? So to solve for d, just take the square root. That's where this comes from. Okay? So those are three formulas. Now I want you to use those to solve this problem, please. So at this point, please pause your recording complete this problem, and we'll discuss it on Monday. Remember, to show a line is parallel, we show what? That's right, equal slopes, okay? So take 10 or 15 minutes and work through this problem, and we'll talk about the solution on Monday. Have a great weekend. Be safe. Hopefully I'll see you at the game Friday night.